today is Data Science and Fundamental and Opportunity from Help University Malaysia. And for today's session is being live streamed on the Universitas STEKOM YouTube channel. And now I will read our agenda this afternoon. First, we will start class presentation by Dr. Logeswaran and continue with the Q&A session after already presentation. And in the next session, we have time for documentation and last time is closing. Okay, and let's begin delivered by class by Dr. Logeswaran. The time is yours.
Okay, thank you very much. Let me just share my screen. Okay, can you see the screen?
Yes, sure.
Okay, excellent. All right, very good afternoon. And firstly, thank you very much to STEKOM for inviting me to be a visiting, to do an international visiting lecture. And it's definitely my pleasure to be here. So today we'll be talking a little bit about data science, fundamentals and opportunities. Okay, so let me just move on. The quick introduction. So I'm Prof. Loges. I'm the Dean of the Faculty of Computing and Digital Technology at Help University Malaysia. And I've been an academic for over 25 years. Okay, and my areas of interest tend to be in image processing, data science, data analytics, as well as artificial intelligence. Okay, all right. So what we'll be going through, I'll go through four main areas. Firstly, start with some introduction, some basics on what is big data, what's data science, what's the difference between data science, data analytics, as well as big data. Then we'll move on to some aspects of data science research, as in some of the techniques or methods that we tend to be familiar with or need to be familiar with. Then, of course, some examples of applications where big data applications applications that have been created using data science technologies. And of course, then also to share some ideas on resources that are available, especially for people who are interested to take up projects in data science. Okay, and before we conclude. So let me just get started here. So what is big data? Right? Now, based on the definitions. So if you go by the Oxford English Dictionary, sorry, let me just, okay. So big data basically is data of very large size, typically to the extent that its manipulation and management presents significant logistical challenges. So this, we're looking from the traditional aspects. If you think of a typical database, its ability to handle typical data sizes, right? So big data basically broke the mold by forcing people to be able to handle much larger quantities of data in a more extended method, shall we say. Okay. Now, in 2011, again, one of the early days of big data, McKinsey came up with the definition that big data is basically data sets whose size is beyond the ability of typical database software tools to capture, store, manage, and analyze. Right. So this created these opportunities and the need to create or to extend the existing tools that we had. Now, as we move on, how can we go around looking at big data? So the definitions were given just now, but if you think of the characteristics of big data, right? So originally there were the three V's, three characteristics they were looking at. Then it went on to four V's and then five V's, and I'll show you some extra V's later as well. But mainly, we think of big data as the first V, which is volume. Right? So large quantities of data. Okay? And interestingly, of course, especially with the modern age where almost everyone's got some kind of electronic device, we are generating data all the time. So even right now, for instance, let's say you have put down your phone and you're listening to this lecture, the fact that you're not using your WhatsApp or any of the other tools, you're already sending data to say that you're not using it. So we're generating data whether we like it or not, right? That's the modern world now. Whatever we do and whatever we don't do even causes us to generate data. So if you look at it that way, you'll find that about 90% of the world's data, existing world's data, was generated over the last 2 years. Okay, and this statistics is also true. If you looked at it last year, you'd say that 90% of the data at that point was generated in the last 2 years. right? Because we're generating more and more data all the time, right? Okay, so that's volume. Another characteristic of big data would be velocity, the speed at which that data is transmitted, stored, used, and so on. So nowadays, of course, we're looking at real time. Everything's real time. The data is moving at real time, right? Some small statistics that's given on the screen there: 175,000 tweets are received per second, right, and beyond. Okay. Then, of course, very important characteristic of big data is variety, right? So again, traditionally, we think of data as in textual form, but realistically, nowadays, we have all kinds of data, right? So text, images, videos, audios, remote sensing data, and location data, and so on and so forth. Right? So the way we generate data most of the time, let's say if we're using social media and so on, we generate a lot of unstructured data, right? And that seems to be the bulk of the data now. So if you think about it, about 80% of the data that we have, that we are using these days, is actually unstructured data, right? And the fourth V is veracity. Now, veracity talks about the quality and accuracy of the data. Okay, so this is something that is a big concern now, because you have a lot of data and you don't really know if the data is true, is accurate. Okay, partly because unfortunately we have people out there who, for some reason or other, create spurious data or false data. So you have those kind of groups out there. You have people who accidentally create wrong data without realizing it. Okay, they may be feeding in the wrong inputs, or they may be putting the wrong information in the wrong columns, for instance. So it becomes very spurious, right? And so on and so forth, right? Especially when it comes to unstructured data, we may need to know the context in order to understand how the data is to be used. So these issues are one of the concerns actually when it comes to big data. Now, ultimately, we use all this, we use data, big data, in order to create value. So if you look at the central part of my slide there, it's basically turning big data into value. So that can be considered as the fifth V, right? Value. And that is actually the most important ultimately, because no matter what you use the data for, whether it's for business, for government purposes, for services, and so on, it is actually to bring in some benefit, right? So that's the traditional V's that we see. And if you look at the aspects of how the data has changed over time, right? So if you look at, let's say the top part there, the veracity, the velocity. So let me just, okay. So if you think of velocity, originally we were looking at batch mode. That means what, a set of data going out at a time. That moved on to periodic data, and then near real-time data. And now, of course, everything we expect is fast. It has to be real-time, right? So that's in terms of velocity. In terms of volume, again, those days we were talking about bits and then bytes and then so on, kilobytes and all. That was a large amount last time. Now, of course, we go on to megabytes, gigabytes, terabytes, petabytes, zettabytes, and so on, right? So the amount of data that we use, that we continuously operate on, has changed tremendously. In terms of veracity, the influence, or the, if loosely put, you could say the corruption of the data could be due to noise, could be due to incomplete data, right? Because that's why I say we need to understand the context very often when you're processing data. The data could be biased. One example I like to give is, for instance, let's say all of us are sitting in a restaurant and we're eating, right? And when we do a survey on, okay, how was your experience in the restaurant, you might find, let's say, 10 tables saying, okay, it was excellent, and one table might say it was terrible. Now, if you don't understand again the context, then you might think like, okay, why is it so weird? Why is it one table saying it's terrible? And if you ask everyone at the table, they might turn around and say, yes, it was terrible. It could be that maybe the location of that particular table, maybe it was under a leaking air conditioning unit. So they had a terrible experience because they were putting up with leaks, for example, right? Or maybe they were too close to the kitchen and there's a lot of smoke and smell there. So these are things that we need to know, right? So these are veracity issues, right? Where you need to actually clean the data before it's processed and used to generate useful information. And variety, of course, again, traditionally you have data that's in textual form, usually input in the table form. And then it went on to databases. Then, of course, data in terms of video, photos, audio, and so on. And then, of course, mobile data, social social media data, sensor data, and of course now a lot of unstructured data from all these various sources, right? So this is just to give a feel for how data has changed over time. All right. Okay, so you can think of in terms of volume, you can think of the amount of data we have as data at rest. Velocity, you can think of think of it as data in motion. Variety, you could think of it as data in many forms, different types of data. Veracity, you could consider it as data in doubt, because we're not sure of the accuracy of the data. And of course, value would be data into money. Of course, it doesn't have to be money per se, but in that sense. Now, the additional, if you actually do a search, you'll find that there's more than these 5 V's. So you have different shall we, companies or different parties coming up with different aspects of how many V's there are to define the term big data. So, but some of the concerns that should be taken into account when you're dealing with big data would be things like vulnerability, where the security issue. We're putting a lot of data out there. What are we doing to safeguard it? Okay. Volatility. How often does the data change? That means, for instance, data that we took yesterday, is it still valid today? Right? Because the world is changing all the time. So we need to know whether the data is still valid. Can it still be used to generate accurate results, right? Or proper results? And of course, a lot of this data science, big data related activities relate to visualization. We want to be able to see the data in terms of charts, graphs, to be able to gauge the trends, to be able to do prediction and so on. Okay, so data science, you could think of it as a multifaceted field. It's a combination of at least 3 obvious fields. Okay, you have, of course, the computer science part, that's the green circle there. You have a lot of maths, right? Especially statistics, because we're dealing with probabilities and so on, right? So you have a lot of maths there. And of the other part that very often people overlook is domain expertise. So for instance, let's say I would like to do some data analytics on agriculture. What would be required then is some domain expertise in agriculture, so that when I analyze and I come up with the trends, I understand what it is and I can then put forth proposals or put forth action plans related to agriculture. So similarly, let's say if I'm doing data analytics on dentistry, right, on teeth, I may not know that. So I need someone then who comes from that field, who understands that field enough to be able to contribute effectively to the data science effort. So therefore, we have computer science, maths, and domain expertise as the 3 main parts. And that then contributes to things like statistical research, machine learning, data processing, and so on. Right? Okay. Now, as we go along, we should also be able to distinguish between these different terms, which you come across very often. You have data science, you have data analytics, you have big data. So let me start from the right. Big data, we've been talking about it just now. It is the data itself, right? So you talk about the actual raw data or the semi-processed data or even the processed data that you have. So it refers to the voluminous amounts of structured or unstructured data that the organization can potentially mine and analyze for business gains. Okay. Then you have the middle column there, data analytics. So data analytics is the process of examining the data in order to draw conclusions about the information they contain. Okay, and this is increasingly done by using specialized tools and systems, right? And of course, the leftmost is data science. So data science is the overall, the big picture, if you like. It is the field that refers to the collective processes, theories, concepts, tools, and technologies that enable the review, analysis, and extraction of valuable knowledge and information from the data. Right? So that's basically how we look at it. Data science is a field, data analytics is what you do with the data, and big data is the data itself. Okay. And of course, the rest of the information I've given there, it's just for interest. These are the kind of things you can do with it, and also some idea of the kind of salaries that people in these fields tend to gain. Yeah. Okay, so for those who are interested in doing data science, there are some aspects that we would, of course, need to know, and that includes the data flow process, data discovery process, and what frameworks are used, data science outcomes that are expected, and of course, some of the what kind of software skills would be useful for a person going into data science. Right? So let me start off with this. This is the data flow process. Okay, now data flow process basically means what happens to data from the beginning when you think of what data should be collected, right? And that's the beginning, the information requirements there, all the way to churning out recommendations and action plans, okay, which is the right. So if you look at this, once you have figured out what kind of information that is required, we collect the data. Okay, so that's operational data there. We collect the data and we store it usually in databases, data warehouses, and so on. Okay, so we may have multiple sources of data coming in. Now, in this process, what tends to happen is you will tend to do some data selection, select the data that you need, clean the data, enrich the data by augmenting, adding on extra pieces of information that may be useful for the purposes of the project that you're doing, and doing other things like disambiguation, right? Trying to make sense of it and so on. Now, if you go through this process, 60% of the effort and also jobs that are available tend to be in this particular first part itself, which is the data selection cleansing part. Okay, so that's something to take note of because when people go into the data science field, generally they become data professionals. And when you become a data professional, it's the different parts of the data flow process that you work in. 60% of the jobs are actually in the first part itself. Now, next 20% deals with the data mining, where you deal with algorithms, you build algorithms, right? You do some coding, programming, and so on. You do modeling. Okay, so that's the middle 20%. So here is where you play with the data essentially, right? So you model data, analyze the data, and so on. And then the remaining 20%, this is the higher end work, which is on the analysis, reporting, and action recommendations. So this is where you come up to become more towards the data scientist part of it, right? So here, the people in these jobs usually at the high end. Think of it as the chartered accountant kind of thing. So this is the data scientist who will then take all this information using the models and so on, analyze, come up with the findings, come up with the recommendations, propose action plans to the top management, the CEOs, and so on. Okay, so that's the data science process. And again, like I said, 60% of the job is in the first part, about 20% of the jobs in the middle part, and the top 20% of the jobs are in the last part. Okay, so what kind of research outcomes or what kind of uses are there for data science? Among other things, for prediction and time series modeling. Right, this is the most popular one where we use existing data or past data, if you like, in order to be able to predict future outcomes. Okay. Then there's, of course, visualization of concepts, to be able to visualize, for instance, to be able to see where certain things are happening. Okay, you have things like heat maps and so on, to be able to get a feel for where certain things are hot, for instance, or where certain things are frequently happening, where things are not happening, you know, what movements of let's say if you talk migration patterns and so on. Then you have the data analytics engines, creating the data analytics engines themselves, and means playing with the algorithms, coming out new models and so on. You have the pre-processing. This was, I said, the first stages now. They deal with data cleaning, integrating multiple sources of data, normalization of the data, disambiguation, and so on. You have then creation of analytics tools, creation of libraries, creation of prototypes. Okay, that's a big deal as well. And again, this will help other users, right? So you can do a plug and play of different types of tools that are available once you have them in the libraries. We also have other work related to guidelines, creating guidelines on how data should be used, how they should be stored, data security, analytics, the effects of analytics, okay, and so on. Coming up with proposals, coming up with frameworks. Then, of course, a very popular one would be to come up with applications, right? So big data applications, coming up with enterprise solutions that are based on data. And many, many more, of course. These are just some ideas of how this data science has become a big deal, right? And how it's very useful for the current and foreseeable future. Okay, so the knowledge discovery process, again, there are various models that can be used, but the KDD model itself, right, the knowledge discovery process, is basically the movement from original data, okay, all the way up to gaining the knowledge out of it, right? So you basically do data selection, you select the data that you want, that becomes your target data, you pre-process, you take the pre-processed data, you do some transformation into the forms that you need to, then do data mining, right, in order to extract the patterns within the data, and then do interpretation in order to form knowledge. So interestingly also, if you notice, highlighted the part where data mining is, just to note that data mining is one part of the entire knowledge discovery process. Right? Now, another model that is very popular when we deal with data science would be CRISP. So, excuse me. Okay, it's the CRISP DM framework. CRISP DM stands for the Cross-Industry Standard Process for Data Mining. So that's basically what you see on the slide here, where you start off with the business understand what is the project for essentially. Then you do data understand the data that you have or you've collected, right? So in there you might do data exploration, data selection. Then you do data preparation. So data preparation, the popular process here would be feature engineering. Then you do data modeling, okay, where you predict outcomes. Then from that, you have the evaluation. So evaluation, you might do things like blind tests, come up with the evaluation matrix and so on. And then you move on to deployment. Okay, that's if everything goes on. So you have user acceptance testing, automation, and so on. Of course, from the evaluation, you might find that things didn't work out so well. Then you go back and go do your business understanding again, study your project objectives again, business objectives again, and go through the process. Right. So this is typically the CRISP DM model. Okay, this is basically to give a feel. A feel for what are the skills that are typically sought after. So in this case, software skills. What are the software skills that are typically sought after for a data scientist? Right. Now, in terms of languages, the most popular language that a person should know if they're going into this field should be Python, because many libraries and programs are written in Python. Right. So that's something you should know. Now, what used to be very popular also is R programming. It's now lost a little bit of its popularity because Python has become more prominent now. But again, it's useful to know R. You have SQL, because you're dealing with a lot of databases, so you should know some SQL. You have Hadoop. You have some of the SAS tools. Java is still useful, still being used a lot. And then you have things like Hive, C++. Then other tools such as MATLAB, right, SPSS, HBase, and so on, still useful. JavaScript is still there as well as a very useful software skill, right, for many data scientists, and so on and so forth. Okay, so there are a whole host of software, but the reason I put this up is to give you a feel for what software you may want to pay attention to if you're going down this field. Right. Okay, again here still in relation to programming languages. Now this one is not specifically for data science, but again get to have a feel for how popular programming languages are and basically how they relate back to those languages we showed just now for data scientists, right? Again, number one tends to be Python. So it's now the most popular programming language in the world, right? Java ranks second. You have C and C++, okay? JavaScript, R, okay, and then you have Arduino, Go, Swift, MATLAB, and so on. Okay. So on this particular slide, on the left is actually the data that I got from 2020. Now, from 2023, right? So almost 4 years later, what we find is that the order of these languages have changed a bit, but they're still very related. So Python is still number one, Java is still number two, C and C++ have changed positions, but they're still 3 and 4. JavaScript is next. Okay, then you have C#, SQL, Go, right? Then R is also still there, still among the top ones. It may not be in the same exact order, but it still shows that these languages are still popular over the last so many years as well, right? So if you're planning to pick up some languages, these are languages you should pay attention to. Okay. Now, in terms of algorithms, data science, although it may sound very sophisticated, very often the algorithms used are algorithms that we've actually been using for a long time, right? It's all related back to maths. So the most popular algorithm is still regression, right? Followed by clustering, then decision trees, visualization, okay, k nearest neighbors, principal component analysis, statistics. Then you have random forest, time series, and text mining. Okay, so these are the most popular algorithms. Again, very often you find that regression, clustering, decision trees, visualization, KNN, this PCA, for instance, these are all very popular algorithms that are used in many, many research projects anyway, right? So again, worthwhile to explore these if you're interested. Okay, so moving on then to applications. What kind of applications benefit from data science? Okay, so some of the projects that have been undertaken in the past, again, I'm giving you just a very small, very brief glimpse of the kind of projects, right, that we, from the large array of projects that have gotten around in the last, say, 5 to 10 years. Okay, so some of them include extreme weather projection and visualization, right? This is a big deal, especially now with all this climate change happening. So being able to predict weather more accurately, to predict the effects of those weather, the potential disasters, for instance, it's very, very important in order to save lives, to save property, and so on. Now, how does the traditional, let's say, weather prediction differ from using data science? So, of course, data science uses the traditional data. But one of the ways that I tend to advise my students is that if you're going to do data science, it's also good for you to use multiple sources of data, right? Because that's one of the characteristics. We look at variety of data, for instance. So it'll be good to look at what are the other sources of data that could give you a better understanding of the situation in order to predict actions in a more accurate manner. Okay, so let's say if you use the last 20 years of weather pattern data. Okay, that's very good. Yes, we should, right? So that becomes the base data to use. But then again, if you think about it, are there any other potential influences? Example, volcano erupting, right, could affect the weather pattern. So that might be some additional data that you may want to put into. It's not just the weather forecast or not just the temperature and the humidity data that you have over the last 20 years. You may want to then take some current information that is not directly weather related, but affects the weather, right? So this is something you might want to put in. So maybe the gravitational pull, maybe there's, like now we have a baby moon, right? The second moon appearing and so on. Does it have an effect? So these additional pieces of information could come in very useful in order to more accurately predict what will happen in the case of the weather. Okay, and of course that general advice also works for anything else we're doing. I would say data scientists are slightly different compared to the traditional fields because we tend to try to maximize use of the available data in various forms from various sources to be able to analyze it more in depth in order to come up with more accurate action plans and more accurate predictions and so on, right? Okay, so another example here, sustainable budget, how to come up with sustainable budget, how to optimize the nation's financial health. So again, here, when it comes to economics, for instance, there are various influences, right? Factors that influence the way the currency works and the income model, the expenditure model, and so on. So again, data science comes in very useful because we're dealing with huge amounts of data from huge numbers of sources of data, right? Covering various types of data and so on. Okay. Dengue hotspot prediction. This is a major issue, right? Dengue is typically on the rise, including in Malaysia. We tend to have dengue outbreaks from time to time. So being able to identify the hotspots and then taking preventive action is very important, right? So we could do fogging, for instance, to eliminate the mosquitoes before we actually have an outbreak, right? Smart manufacturing, again, capitalizes on the use of data science or use of data, shall we say, in order to be able to reduce costs, to, let's say, produce uh, based on demand, right? So to predict production patterns based on predicted demand, right? And so on. Customer spending behavior. Okay, in this particular example, excuse me, in this particular example, we're talking about behavioral analysis to increase bank revenue. But let me give you a broader perspective of this. Customer spending. Most of us, I think, one way or the other, we have things like loyalty cards, right? When you go to a shop, a retail outlet, a supermarket, a mall, we tend to subscribe to this free again, let's say, loyalty cards, right? Where when you use it, they give you bonus points, which you can then get maybe discounts or exchange for certain goods and so on. Now, remember that every time you purchase something and you use a card, the information is gathered, which means that these retail outlets have collected information on your purchase behavior. So they know when you go around purchasing what kind of items, right? How often, how much you purchase, and so on. Now, using this, you could think of it as maybe not in the too distant future. As you walk into a shop, the shop might greet you, right? But hi, so and so, hi, Loges, welcome to the shop. Today, you are probably going to buy this, because by now you should have finished. Example, your toothpaste should be finishing, your coffee should be finishing. So so most likely you need these items, and it might then give me, maybe even highlight my path, the optimized path for me to go and get all those items. So even though I may not have realized that I needed so many items, the shop probably knows it because they've collected all this data and they've analyzed it, and being able to predict the intentions and the needs of the person, right? So that's one. Another thing that we see a lot, and I think this is also worldwide, is that usage of data to predict where services are needed, right? So as an example, if you look at ambulance, right? So ambulances need to get to places where they are needed. That means emergencies, accidents, and so on, as quickly as possible. Traditionally, ambulances were parked at hospitals. But nowadays, you'll find that many a time ambulances are parked at certain strategic locations that are not the hospital, because they would have been able to analyze where they've been needed the most, where there are, say, likely accident spots, where there are disaster spots, where there are certain illnesses happening very often. And then they park the ambulances closer to those areas so that they can reach the potential patients or victims as quickly as possible, right? So similarly, tow trucks, right, for car breakdown and so on, they tend to capitalize on this in order to find the optimum places to be positioned in order to provide assistance as well as to improve their business opportunities, right? So all this essentially helps the businesses grow, helps the service providers to provide service at the best times, right? Okay, and then of course the last example there, increasing retail revenue. This is ultimately the most important because a lot of innovations come about when there's monetary benefits to it, right? So businesses are more interested in doing something if they can actually gain good rewards out of it, right? Sorry. Okay, so I just put up some examples of applications that have been built using some data science concepts here. So example here, this is flood and flood disaster monitoring, right? So an integrated mobile solution for alert search and rescue was created, where this app automatically monitors the water level at the dams and rivers in order to predict whether there's going to be floods, right? And forecast the water level. It detects overflows of the dam or rivers, and proposes water channeling to the catchment areas in order to reduce the likelihood of flooding. Okay, if there is a overflow, that means if floods are likely to happen, then the various government departments that are involved in flood services, such as the police, the armed forces, the civil defense force, and so on, are alerted and activated, okay, through the app. Then, of course, the medical side itself. right? The Red Crescent, Mercy Malaysia, and so on. These other non-governmental organizations and volunteers are also alerted so that they can provide NGO, non-governmental organization support to these potential victims, right? And of course, then the system itself keeps monitoring and provides real-time information to all the users so that they know how to avoid those areas or how to provide assistance if they're interested to do so. Okay, another app created. This was through one of the university challenges. Okay, this was the congestion and accident prediction system. So here it's something like what we use. We have Google Map and Waze and all those to find our ways from point to point. So this is a similar type of app where they predict collision, they predict traffic jams, and using information such as time, weather, events that happen in order to then propose alternative routes to smoothen the journey. All right. Now, data science has a huge impact on other fields, including the medical field. Right. So for medicine, now of course AI is the big deal. AI has been able to gain the benefits of data science in order to give it good training, good amounts of training data in order to improve accuracies. So an example here, okay, this what I'm showing here is where the AI outperforms doctors in detection of multiple diseases. So this is still a data science related project because for the multiple diseases, you have multiple features, multiple amounts of data, multiple modalities that are tested, examined, collected, collated, cleaned, analyzed, right? With prediction models and computer aided diagnosis that goes on. So all that involves data science. Okay, and then of course to the training of the AI engine before the final diagnosis decisions are made, right? So all this is still related to using data science in order to improve such systems. Okay, so this particular example, the system was then able to handle or predict and detect, diseases all the way from the common cold, flu, and asthma to life-threatening pneumonia, meningitis, right, and so on. And the system was shown to be able to outperform the actual primary care physicians. Okay, now the data science is used in so many different fields. So example, for instance, education, by having all this data available, it helps us now move on to better curriculum planning, better job matching, right? Identification of training needs and providing the necessary training in the areas that are needed, right? For food related aspects, for food production, right? Using the data, we can then better predict what is required. We can better analyze what works, what doesn't work, what kind of, for instance, soil is required, what kind of treatment for the soil. When is it we need to do certain things such as maybe watering or pesticides or fertilizing, right, and so on. So all this can be analyzed and done more accurately, and then of course automated. Yeah. So for food production, for weather pattern detection, recognition, and forecasting, for demand forecasting, okay, in order to be able to grow what is needed in anticipation for the demand that is coming up. So that means we will reduce the possibility of overproduction and wastage, yeah, as well as we will also make sure that there's sufficient supply in order to meet the needs of the demand. Okay, then of course crop cycles. When should we change what crops we plant in which areas in order to make sure that the nutrients are replenished and so on. So all this can be done again through data science because the available data can give you enough information to be able to alert us or inform us of the necessary actions and the timeliness of it. Okay, next for crime. Okay, for instance, efficient police deployment by being able to chart out where are the hot crime areas, right? And we can actually then go around to advise the police where to place police personnel in order to reduce the potential crime, or to be able to at least be present at the site as quickly as possible in order to prevent or capture the criminals. Right? For energy sector, we have the ability to then forecast demand surge. Right? This one is very important because an unexpected surge can bring down the whole electricity grid. Right? So being able to forecast demand surge is important. To be able to forecast, for instance, hydroelectric supply, to pump it up, ramp it up, or reduce it as necessary, to be able to predict what will happen in case of weather. For instance, if it's going to be a thunderstorm, then necessary actions can be taken, right, and so on. For health, we mentioned just now, but being able to handle patient information, right, patient care, again, to better analyze the needs, especially in the aging population. All these kind of things, data science comes in useful uh, to for the case of analyzing environmental effects, right? To curb the spread of diseases, okay, to handle multimodality examinations, right? Again, variety of data, to understand the patient history better, to collate them, to allow this patient history information to be shared across various institutions, because each institution, medical institution, would have maybe different amounts of data, to be able to put it to come up with consolidated patient information so that the doctors or the medical practitioners have the accurate information and are able to provide the correct care and treatment, okay, and so on and so forth. Okay, so again, more areas, more sectors that benefit from data science. Retail, of course, in terms of customer scoring, in terms of store siting, where to place the store itself, where to put the shop, right? Then, of course, if you also notice the layout within the shops, I believe it's true for Indonesia as well, but Malaysia and many other countries, if you go into a typical supermarket, you find that the way the trays or the racks are arranged, the way the items are placed, it's become almost now standardized and optimized based on the data that they have from the customers. Okay, that's why those days we used to joke that, okay, let's say if I was to go shopping, I'll have a shopping list, I'll go to a shop and buy only those things. But nowadays, if you go into a shop, you find that you're easily tempted by a lot of other things, and you go back with buying a lot more than you originally planned to. This is all again through the data science. Okay, example I like to give, even from those days, is that I heard this case in America. Okay, before data science became very big, they used to put in certain shops diapers, baby diapers, and alcoholic beverage side by side. Okay, now this doesn't seem to make sense because baby diapers should be in the baby department, right? Or kids department, and alcoholic beverages should be in the drinks department. But they did this, they put it close to each other. And then now you think about it, it was probably because the way the buying patterns were. So if you think of, let's say, in a typical household with a baby, the mother might tell the father, go buy diapers. And if you think of it again from a man's perspective, it might be not very macho in order to go and buy diapers. So what they may do is okay, they'll go and buy. And again, it being the Western countries, they drink a lot, right? So if they see, okay, they pick up the diaper and they find, oh, look, there's also drinks next to it. They'll probably pick up the drink as well. So instead of just buying diapers, they'll probably buy diapers and the drink. And what they noticed through this is the sales for both diapers and drinks went up, because now suddenly, instead of the father telling, informing the wife that, okay, I'm going to go buy drinks, they probably say, oh, I'm going to pick up another pack of diapers, right? As a good excuse. So sales just skyrockets. This is just a very simple example of how data can be used in order to improve retail by store layout and product placements. Okay. Now, of course, data science can be used again for fraud detection, right? When you analyze buying patterns, analyze expenditure patterns, and so on, transaction patterns, it's easy enough to automatically then detect fraudulent cases, right? So this is something data science comes in. and therefore you can also implement prevention tactics. For supply chain optimization, again, using the data that's available, this can be done. In the financial services, trading trends can be analyzed, risk analysis can be analyzed, fraud detection again, portfolio analysis, especially when you have different items, all right, or stocks that you have, to do a portfolio analysis in order to improve your chances of, succeeding in the stock market, for instance. This is something that data science can come in useful. For manufacturing, in using data science for product research to identify what products are likely to be needed and what would do well, right, before you actually go around and manufacture it. For engineering analytics, for process and quality analysis, for distribution optimization, and so on. The government makes use of data science for market governance, for potential counter-terrorism, for econometrics, health informatics, right, to provide services where they're needed, and so on and so forth. For advertising and public relations, using all this vast amount of data, it can actually be used for demand signaling, advertisement targeting, right? So that you consolidate, and this is happening already anyway, right? If you go and do a search for a certain item, let's say I do a search for beach vacation, right? Later on, you'll find that advertisements that come up are related to holidays, seaside, and those kind of things, because they're using the data and pulling from that in order to target the advertisement that comes to you. Right? Sentiment analysis to identify whether people are happy with a certain product or certain place or certain service. Right? Customer acquisition, to get more customers. Again, data science comes in very useful. For the media and telecommunication sector, for network optimization, to make sure there's minimal drop rates in the calls, right? For load balancing, those kind of things. For customer scoring, for churn prevention, fraud prevention, these kind of things. Again, data science is very useful. The energy sector uses data science in managing the smart grids for energy exploration. For instance, if you want to explore potential mining areas, using the data that's available, you can get good ideas of predicting where potential resources are. Then, of course, healthcare, we've already talked about it, but including the pharmaceuticals and so on. Okay. Again, to give you a feel, maybe I'll skip this part here, but just to let you know that in the oil and gas industry itself, analytics is used a lot. Analytics depends on data, right? So use the data analytics. So basically, it's data science related, right? And there's a lot of money being pumped into this. Okay, so again, this is still oil and gas. We're talking about the different parts, right? Midstream, downstream, upstream operations, and how analytics are used. So, for instance, let's say in midstream operations, the fleet analytics, the vehicles itself, how many vehicles are required, what is the optimal routes to be used, right? And so on. Use that. You have storage optimization analytics. For downstream, you've got pricing. How much should you charge for petrol, for instance, right? Commodity trading analytics, refining analytics, demand forecasting, right? And so on and so forth. All right, I'll skip that. Now, with the Internet of Things, right? Big data analytics is very, very important because IoT produces a lot of data. So when you have huge volumes of data, obviously it's big data. Obviously, data science comes into the picture. And IoT generates a lot of data, for instance, in the industry, right? The logistics part, the industrial robots, the factories, construction machinery, all this provides lots of data, right, through IoT. For domestic life, you have digital appliances, robots, computers, smartphones, other electronic devices that may be IoT enabled, that again provides a lot of data. For infrastructure, you have the transportation, automobiles, you have railroads, you have aviation, planes, and so on. You have pumps, ships, you have the photovoltaic cells, right, for the electrical grid, solar energy, and so on. All this provides a lot of information, a lot of data that comes in that needs to be analyzed, and then of course action taken accordingly. Action might be in terms of visualization, it may also be in terms of action plans for recommendations. Yeah. Okay, modern construction again uses a lot of analytics. For instance, when you use drones to monitor construction status, to be able to automatically identify the information that's available through this data. You have robots, right? The use of robotics in construction. You have remote monitoring. Again, a lot of analytics goes on behind that. So if you see 65% of the analytics is for remote monitoring itself on sites. You have RF identification to track equipment. You have smart sensors. You have building information modeling, right? And so on and so forth. So all of this again uses a lot of data, and a lot of data analytics goes with it. Agriculture, right? Sensors are used, okay, to capture farm data and upload it to the platform cloud, to the cloud, for instance. That data is then again through data science process, of course, is analyzed, right? So you have the analysis of the data, and then this is usually the results of the analysis usually passed on to the farmers and the other players along the way. Prediction, okay, so the captured data can be used to predict the models, to create prediction models in order to come up with the decisions on how to, the ideal growth patterns, for instance, the requirements, how to control potential plant diseases, let's say pesticides and so on, if necessary. Sorry, not pesticides. Yeah. For what plant cycles, crop cycles, and so on and so forth. Okay. And of course, from that, the recommendation comes up where the action is taken, which may include things like, say, watering or fertilizing and so on. Yeah. Okay. Another thing, when we talk about data science, of course, it's important to have visualizations. So there are various types of tools we use to visualize, and then various visualizations that can be used in order to get a better feel for what's happening with the data, right? So one example, of course, is this, which is a cloud, the word cloud, if you like, right? Where you can, from that, you get a feel for, okay, which pieces of information or which words were prominent in a particular context, let's say a set of documents. Yeah. You have heat maps, which tell you where the hot areas are for certain things, depending on what you're trying to plot. And you can overlap them or augment them with other data. So for example, this, the top image there, that's a map, right? So the base is a map. Then you have the heat map on top of it, which might, example, maybe indicates the high crime areas, right? The redder it is, maybe the higher the hotspots for crime. And then you can overlap maybe with the blue here, the bars, maybe police presence, right? So this might be where you want to place more police presence in places which have maybe higher criminal activities, right? So putting these different pieces of information that often sits in different databases together, visualizing it gives us a clear view of what's happening, and it's easier to then explain the action plan as well as take the necessary action to effect the change, right? Okay, so bottom one is just a scatter plot. Now, visualizations could also be in more interesting manner. So this is so a modified pie chart where this particular figure, for instance, it's a more infographic which gives you information on the proportions, right, through the pie chart there, but also labeled with additional information, okay, and also icons. So at a glance, it provides a lot of information that again probably came from multiple sources, right? So this one, for instance, what do 7 billion people in the world do? Okay, so if you look at the top right, it says 1.9 billion are too young to work. So these are people between the ages of 0 to 15. Then you have 1.7 billion workers in the service industry, 1.4 billion in agriculture, 800 million in industrial jobs, right? 577 million are older than 64 years old. 430 million are unemployed, okay, and over 400 million are entrepreneurs. So it gives us a good picture, again, possibly from multiple data sources, and at a glance, we get a good feel for the information, right? This is another one that I like. It's got lots of information. It's regarding a comparison of two countries with in terms of many features, right? So for instance, in terms of the usage of social media, GDP, brands, market capitalization, military expenditure, unemployment rate, even Olympic gold medals, right? How they compare against each other, literacy rates, and so on and so forth. So again, this kind of visualization allows you to take lots of different types of data, different sources from different sources, put them together, and in one go, give you a good picture for easy comparison and analysis. Okay. I always believe that if you can see it, it's easier for you to analyze. Otherwise, it becomes very difficult to make sense out of the data that's there, right? Okay, again, more examples of visualizations that I used. Okay, moving on. All right, again, I'm just putting it up just to show that there are different ways we can visualize in order to be able to come up with our conclusions. All right, now moving on towards the last part of my talk, resources. Now, if people want to take on data science projects, the first and most important thing, of course, is to have data. You don't have data, you can't really do data science, can you? So the biggest problem tends to be, where can you get data? Okay, so here I'm mentioning open data, and then of course look into some of the tools that are available as well. Right. So the open data initiative was undertaken, or has been undertaken by many countries around the world in order to provide useful data to be analyzed further. And of course, the hopes obviously of putting all this data is that the analysis can then benefit the country again. Okay, so Malaysia, for instance, we have the data.gov.my as the portal for the data. US has data.gov. Indonesia has data.go.id, right? And so on and so forth. So here I've just given a short snapshot of some of the countries. And in addition to countries, there are also other organizations that provide a lot of data as well, such as the United Nations, the World Bank, the EU Open Data Portal, and so on and so forth. Okay, and the way the data is arranged may be different, but the amount of data that's put up has been growing over the years. I'll give you a Malaysian example. When I first looked into it in 2015, there were only 653 data sets. Okay, about 9 months later, it doubled to 1,292 data sets. Then about a year later, it doubled again, right, to 2,500 data sets. And then a year after that, again, it went up by almost 2,000 data sets. And by 2020, there were 13,600 over data sets available. Okay? So the amount of data, as I said, has been put up. The amount of data that's been put up has increased tremendously. Okay, this is an example from India, where they have over 625,000 resources for the data under the Open Data Initiative. Right? Okay, and I like using this India example because the data is often clustered, right, into different sectors, so that it'll be easy for you to look for data in a particular sector. So as an example here, they have sectors for agriculture, arts and culture, let's say water and sanitation, defense, economy, education, environment, what else? Housing, industries, power and energy, transportation, and so on and so forth. Right? Okay, now a quick snapshot of the tools. In order to do data science, traditionally everyone is worried about, you need to be an expert in computer science, for instance, to be able to do it. Okay, but as I've shown you, data science is actually not just computer science. Computer science is one major category, but your maths, understanding maths is important, and of course domain expertise is important. In terms of applying data science, there are many tools available, right? And there are so many tools out there that requires very little programming, such that almost everyone can pick up on it. Okay, and nowadays, of course, within the age of AI and all that, you can actually do almost no code or low code programming if required, in order to come up with data science. But very often, again, many tools are there already that you can just put your data in there and it can generate the necessary things for you without you actually having to do almost any coding at all. All right. So just if you look at the slide I put up here, don't worry if you can't read the words or even identify the icons because they are really small. I was just trying to show that there are so many tools out there, and this is just a tiny fraction of what is available out there. Okay. So let me just give you a bit slight feel for it. So you have tools that deal with the infrastructure to be able to handle big data, right? You have Hadoop, Spark, cluster services, NoSQL databases, okay, and so on and so forth, right? So just giving you a feel for it. Some of these icons would be familiar to you, the others may not be, no worries. Just a feel for, okay, again, like I said, many tools out there, tools including to handle cloud, data transformation, security, storage, and so on and so forth, okay? For analytics, again, lots of tools out there, right? For as analyst platforms, for data science platforms, for visualization, business intelligence platforms, statistical computing, okay, analytics, social analytics, real-time analytics, machine learning, speech and natural language processing, okay, search engines, and so on and so forth. For application development, again, tons of options out there. Okay, so again, I'll just leave it up here for you to have a look at it. Right, even on the legal side, for publisher tools, finance, education, life sciences, industries, etc., etc. Okay, you have cross infrastructure and analytics tools as well, which are provided by the big names typically, Amazon, Google, Microsoft, IBM, SAP, SAS, HP, etc., etc. Right? And of course, there are, for those of us who may not want to spend much on this, there are lots of open source tools available. Okay, so you have lots of real-time tools, statistical tools, machine learning tools, search tools, security, visualization, framework, data flow tool, data access tools, coordination tools, and so on. Right. So there are lots of options. Like I said, this is only a tiny snapshot of what's available out there. There's so many more out there right now, and even under open source, there's so many out there. Right. So if anyone wants to embark on this, it's fairly easy to get started. Okay. Data sources and APIs, again, many are already available for health, IoT, financial, economic data, air, space, sea, location. Okay, and there are also incubators where if you want to learn about data science, again, many providers out there provide free training on at least the basics of data science. Yeah. Okay. Before we end, want to also make sure that get this concept across. So we talked about data science handling large amounts of data from various sources in various forms. So one of the things is, instead of thinking of database, typically if you think of data science, you should think of data lakes, okay, which is basically the storage repository that holds vast amounts of raw data. Actually, it's not just raw data, vast amounts of data in various forms. Okay, so if you look at this, you have raw data, okay, such as logs, events, PDFs, and so on. You have streaming data, which may be unstructured data. You have databases, right, sending in data as well. You have custom data, where you may have semi-processed data, reports, and so on. All this can be put into a data lake, right? And then it's used as needed, right? Maybe in batch form or streaming form, interactive form, or through APIs and so on, right? So this is typically the ecosystem for data storage and handling, if you like, for data science. Okay, so as a conclusion, I've provided some of the ideas on the fundamentals and the fundamentals of data science, right, and the various opportunities there. Let me leave you with this one. Okay, there are many data science related jobs out there. Let's call it data professional jobs that are not filled as yet. Okay, that means there are lots of vacancies out there. So if you look at the, let's say this pie chart at the bottom, you find that 2/3 of the big data skill requirements are not met due to the lack of skilled professionals. I mean, they are short of people who actually skilled in data science. Okay, and then if we break it down to the different job scopes, you have data scientists. 82% of the jobs are still available. They're still looking for the right people. Big data visualizers, 77% of the jobs still available. Big data research analysts, 69%. Big data engineer, 56%. Big data architect, 57%. Big data analyst, 50%. Right? So these are all vacancies that are still there, which means the job opportunities are fantastic for those who go into data science. Right? So with that, let me thank you for your attention. And of course, we are open for questions if you have any. Thank you.
Yeah, thank you so much for your presentation. And for all participants, if you have any question for the speaker, please add them to the chat or you can raise your hand. Yeah, for first question, we have question from Mr. Abdul Shah, already read in the Zoom chat. For first question, what are the most critical skill one need to master in order to success in the field of data science, especially with the rapid advancement of technology like machine learning and AI? Thank you.
Okay. Thank you very much for the question. Right. Especially in the age of AI, right? Now, I would say the most important would be being able to identify the right tools, right? Especially now, because knowing the techniques, knowing the basics, as what I've gone through just now, these are fundamental. They are useful, especially when you're trying to customize solutions and optimize solutions. But the, the question was more of the what are the main critical skills. I would say identify the right tools for it now, because AI can do a lot, right? So at least at the first step, being able to identify tools that will help you collate the data, analyze the data. That would be first. And then, of course, you build skills on understanding the more detailed models, how to customize in order to improve your results. Yeah, I hope that clarifies.
Thank you. And then the second question, as artificial intelligence continue to evolve, how do you see its role shifting in relation to data science? Do you think data science will become more dependent on AI or will the two fields remain distinct? The question from Ms. Kinan.
Okay. All right. Actually, from the slides I gave you, for instance, the example on the medical part, right? You find that it's already using each other. So AI depends a lot on using data science, right? Because the accuracy of AI, if you like, improves with larger amounts of data, right? Well, okay, I should say larger amounts of accurate data, but that's the idea. So AI relies very much on data science. Will it remain distinct? No, it won't, because AI uses a lot of data science in it. Therefore, I feel that it will be amalgamated, and you'll be basically thinking more of it as AI. But then, do not forget that when we talked about data professionals, there's this whole data flow process. So we still need people who are able to handle that before you can feed it into the AI to do what the AI needs to do. Yeah.
Okay, thank you. And we still have two questions again. Yeah, and the third question, can you give specific example of how data science is transforming industry that are traditionally less data focused, such as healthcare, education, or finance? How are these industry benefiting from data-driven decision making? This question from Mr. Sukanto. Thank you.
Okay, thank you so much for the question. Now, actually, again, based on the examples I've given just now, you'll notice that these are the fields that we talked about, right? We talked about healthcare, we talked about, okay, I didn't say so much about education, but we did mention education, for instance, in curating the curriculum. There, we are using a lot of data science now. And finance sector actually has been using data science for a while because a lot of the time series predictions, prediction of stock market prices and all that has been very much a data science issue. So these industries are definitely benefiting a lot because they are very data driven industries, right? Healthcare is a good example, especially nowadays with the ability of AI to be that can handle this huge amounts of data. The accuracy of the systems have improved to the extent that it's actually surpassing the actual experts, the actual specialists, right? And it is bound to only grow. Similarly, finance sector has been using data related techniques for quite a while now, and now you get a lot of automated processes that have come about to be able to better predict the trends, to be able to advise the human on the investment decisions and so on, right? Education, there are several ways we are going. One, of course, like I said, curriculum development, but also data science, again, together with AI, is also changing the whole education landscape, such that very often the interaction now can happen through data-driven processes um, that use AI engines. Yeah. So yes, these changes are definitely already happening, and you will see a lot more as time goes.
Okay, thank you. And then the last question, how important is interpretability in data science, particularly when deploying machine learning model in critical area like finance or healthcare? So we always priority model that are easier to explain, even if they are less accurate. This question from Miss Febri. Thank you.
Okay, a very important question. So this has been again one of those points of contention for some time, right? Very often we find that many industries started using um, data-driven or automated techniques in order to help them make decisions. But then the issue was that most of these AI-related engines, for instance, they were closed, right, or black box. So it gives you a decision, but you're not entirely sure how the decision came about. So, for instance, if you apply for a loan, for instance, at a bank, they may use an engine, and the engine says, "Okay, sorry, your loan is rejected." Of course, as the applicant, you want to know why was it rejected, right? Because it might be some small item somewhere that, if you knew the reason, you could explain and you could probably get it approved. So for that, explainability is really important, right? And I guess it again goes back to the application or the purpose of the target application, right? In the case where, for instance, the loan example, or even in healthcare where you may want to know why a certain diagnosis or a certain treatment plan was being promoted. You would want it to be explainable. But for many generic purposes, explainability may not be so important. You might be more interested in just getting some accurate results, right? And I think for the masses, accurate results are more interesting. For instance, let's say if I was using a weather app, as a normal user, I would be more interested to know, is the app correct? If it says it's going to rain in 1 hour's time, is it accurate? I may not care much about how it came up to that decision, right? So I guess both sides are important. Explainability is very important for certain things, but accuracy would be more of interest to the masses. I hope that answers the question.
Okay, thank you for answering. I think it's very clear answer from Professor. Yeah, before I close this event, for our participant, please open your camera. I will take a picture on the count of three. Okay, one, two, three. Okay, another one, two, three. Thank you. Thank you for your cooperation. Finally, we come to the end visiting lecture today. We would like to thank you for Professor Dr. Logeswaran for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have more collaboration in the future with Help University Malaysia. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice day.